All right, welcome everybody. This is the ISN review for Big Idea A, and specifically this is going to be for questions A3 through A5. And so we're going to start off with this Prezi, which really does kind of highlight most of everything we're going to talk about here. And A3 through A5 really, since we're going to combine it all together, it really comes down to a basic question. Is there anything bigger than a galaxy? And so that's where we're going with this. So if you were to think about this in terms of you and your address, then of course if you were mailing something, you'd want to put your return address down. But what would you put down exactly? So for example, would you say that you're in Sauk Rapids Rice Middle School? Would you say Sauk Rapids? Would you say Minnesota? Or would you say United States of America? Or would you say North America? Or would you say Earth? So that's what we're going to do. We're going to start from the Earth and we're going to build ourselves out bigger and bigger to larger and larger structures to see how far out can you go? How big would you need to make this return address? So in your notebook, in your notes, what you want to do is you want to start with the Earth and then go larger than that. What's larger than the Earth? Well, the next largest structure, of course, would be the solar system, which you can see a little diagram of here. So next, beyond the solar system, what would be larger than the solar system? The next largest structure, of course, would be the Milky Way Galaxy itself, our galaxy. And specifically, you could even say which arm we're part of, because you can, as you can see right there, we're part of this Orion spur. It's sometimes called. It's a little subdivision of the Milky Way, and so we're part of that arm there. It's actually technically the Pegasus Orion arm that we're a part of. And so there you can see we're part of the Milky Way. But what's larger than the Milky Way Galaxy? As it turns out, there is something larger than the Milky Way. If we expand outward, we can see that actually the Milky Way is part of a larger structure called a galaxy cluster. Ours is called the local group. And the local group for us is dominated by several different galaxies, the Andromeda Galaxy and the Milky Way Galaxy. But galaxy clusters in general can be stated this way. It's where you have dozens or sometimes even hundreds of galaxies all held together by gravity. And so our galaxy, the Milky Way and the Andromeda, are actually held together. They're approaching each other because of their gravitational pull. All these galaxies are kind of falling in towards each other. And so if we were to zoom in and see some of what this would look like, what we're going to see is, I'm just going to speed it up here a little bit. You're going to see our galaxy and the Milky Way Galaxy. What we think eventually it will do is that our two galaxies are going to merge, along with all the other galaxies in the local group. So eventually, over time, all of these galaxies are going to end up merging into one really giant, ginormous galaxy. In this case, you can see it's an irregular galaxy right now, but eventually, as they kind of pass through each other and continue to disrupt each other, they will eventually become an elliptical galaxy, which I think you'll see on the second pass here. Once you get these two galaxies merging together, it creates enough chaos that it creates this large oval-shaped structure, an elliptical galaxy. And likely that's the fate of all of the galaxies in the local group. So is that the largest structure? Is there anything larger than galaxy clusters like our local group? And as it turns out, there are. Galaxy clusters are part of a larger structure called superclusters. And here you can see our local group is part of a larger supercluster called the Virgo supercluster. And you can see a map of all of those superclusters here. These dots are not stars, they're galaxies. And you can see a high concentration of galaxies over here in the Virgo cluster. And we're actually being drawn towards the Virgo cluster so that you have clusters of galaxies all held together by gravity. So that what's the actual motion? Well, we have one cluster of galaxies, as you can see in the upper right here, or the kind of the center right, and another cluster of galaxies over here on the left. And eventually these two clusters of galaxies are going to merge together and become an even larger structure. And so we have these superclusters. But are superclusters it? Is there nothing larger than a supercluster? Turns out there is. Beyond a supercluster, we get to a whole nother range of size called filaments. And filaments are the largest structures currently known to humans. It could be that there's stuff bigger, but we just don't know it yet. And here, filaments are dozens to hundreds of superclusters, all held together by gravity. And they oftentimes resemble threads or tendrils. I've heard them referred to as cobwebs even. And so we're part of the Pisces Cetus filament. And what's this all look like? Well, if you were to look at an entire map or 3D model of the whole universe together, you can see a universe where clusters of galaxies form superclusters, and superclusters form these filaments that are flying around in front of us here. Larger and larger structures. Everything we see here is not a star, not even a galaxy. These points of lights are clusters of galaxies. And we're just one little piece of that. Somewhere in all of this simulation is a tiny point of light, which is part of our filament. And within that filament is our supercluster, the Virgo supercluster. And within that Virgo supercluster is just our local group. And within the local group is just our galaxy, the Milky Way. And within just that galaxy is our star, the sun. And within that solar system is just one planet, ours. And on that planet is you, one of 7 billion people living and thinking about this very thing right here. Kind of opens your brain up a little bit when you think about it. So right now that's the largest structure that we know of. And so if we were to go back to that envelope and look and see what was it you would need to put on here, well, there would be you, and of course the Sauk Rapids Rice Middle School, Sauk Rapids, Minnesota, United States of America, North America, Earth, the solar system, the Orion Cygnus arm of the Milky Way Galaxy, of the local group, of the Virgo supercluster, of the Pisces Cetus filament, of the universe. And the universe extends outward in every direction 15 billion light years, as far as we can see with our strongest telescopes. And that, my friends, is what the universe is. Nothing but galaxies upon galaxies forming larger and larger structures. And we compared it to kind of like one of these Russian dolls where one fits inside the other. I think they're called Matryoshka dolls. And that's kind of the universe. One layer inside of another layer inside of another layer. And we even speculated in class, we don't know that filaments are the largest thing. There could be another 20 layers to this particular Matryoshka doll, and that our universe is quite a bit larger even than we suspect right now. In fact, that could very well be the case. And in fact, the universe could be a lot smaller than what we see right now too, going downward and downward, smaller and smaller. What we do know is that we are just a tiny little speck within this entire universe. In fact, if you want to see the whole thing in its totality here, check this out. From this way up here all the way down to where you are down here. In fact, we can zoom in. Here you are. And so within your notes, hopefully you've been able to capture the Earth, the solar system, the Milky Way Galaxy, the local group, the Virgo supercluster, the Pisces Cetus filament, all the way out to the entire universe, 15 billion light years in every direction. And so that really leads us to our big idea for Big Idea A, which is really the universe is big and we are small. So very, very, very small. But it kind of gives you an interesting perspective when you contemplate it. So there it is. That's Big Idea A, in particular A3 through A5. If you're looking for A1 and A2, that's another video review, which you can find right here on our science website. So until then, good luck to all of you, and best of luck in particular on the science test coming up. Bye.